So section 4.2 is all about solving quadratic equations just by graphing. All right, so we're going to be looking at just the graphs. Can we do it just by looking at some of the information in the actual equation? So the standard form of a quadratic function looks like this, where you have some number in front of the x squared and another number in front of the x plus some constant, some number that we'll see in a bit how it's going to help us. So a is not equal to 0 because if a 0, that cancels x squared because 0 times x squared is nothing, 0. And so if that cancels, then you really have a linear equation or something else. So we just have to be a little, careful about that. And a, b, and c are integers. So normally in standard form, you won't have like 1.3 here. It'll just be a 1 or a 2 or whatever. All right, so then the roots. There's several words. Roots, zeros, x-intercepts pretty much mean the same thing. All they are is where does your parabola, where does it cross the x? So those would be called zeros or roots or x-intercepts. So for example, this particular parabola is crossing here and here. So those two would be considered the roots or zeros. Now, there is a situation, or there are several situations, where you could have a quadratic function, so a parabola, that has no roots. So a parabola with no roots is a parabola that is up here somewhere. It's never touching or crossing through the x-axis. So in that particular case, you would say that there are no roots. If it touches once, let's say the vertex is right on the x, then we consider that having one root or 1, 0. And if you do have two roots, you'll see that the parabola will cross the x-axis at two different places. So note that if they ask you for how many roots, you're going to give pretty much, there's 3 different answers you could probably give when you're doing these type of questions. So now let's look at your packet. So if you notice, your packet for section 4.2, solving quadratic equations, has pretty much the same vocabulary that I listed for you. And then it gives you some equations of quadratics for you to graph. You can make a table and so on and so forth. So basically, it's a little bit of the same that we've done before, but now they've included those words such as zeros and roots. So those are those intersection points, the x-intercepts, that you're going to be looking for. And so that's just a little bit more practice. Here is the information that I gave you for your notes. So whether you're going to have 1 root, 2 roots, or just no real solutions because the parabola doesn't even touch the x-axis. So go ahead and practice those by graphing them. Like I mentioned, you can use a Desmos.com software where you can use that as a place to do your graphs if you don't have a calculator. Desmos is DESMOS.com. And there is also a calculator you can download for your Android device. It doesn't work on Apple, but it does work on Android, and that would be the Wabbit Emu. So WABBIT-EMU. It's a Wabbit emulator, so it can emulate a calculator. So at least you can have access to like a TI-84 if you want to do that. If you need more information, just contact me. And I can help you with that. I'll give you my contact information, I think, in the introduction video. All right, so let's continue here. So again, more information about graphs and how to graph the quadratic equation. So go ahead and continue working on those, even on estimating roots, because sometimes if you notice, the root is going to be almost 4, almost 0. So at least it's between 0 and 1. Here it's going to be between 3 and 4. So you can kind of give an estimate. Sometimes it doesn't have to be perfect, but at least you'll have an idea of what it is. So in your practice problems, you'll see that it's asking for the solutions. So solutions, roots, zeros, etc., pretty much the same thing. So in this particular case, it looks like it has 2 solutions. It's crossing at x equal 1 and x equal to -3. So those would be 2 roots, 2 zeros, 2 solutions, etc. Here, it looks like there's only 1 one solution because it's touching at -1, -3. So those are the kind of things you're going to be looking out for here. Obviously, see, it does not even touch the x-axis, so there are no solutions. So the word solutions, x-intercepts, zeros, and roots all mean the same thing. So, and notice how solve each equation. If you can't find the root, just, state whatever integers you see it between. It's between 1 and 2 or 2 and 3, etc. So those are the type of problems you're going to be working on. So now let me go ahead and do at least one of these for you. Most of these are in standard form, but I do notice that number 8 isn't, so let me work with that one right now. So I notice a couple of things. As long as it's equal to 0, it's in standard form, so I could easily graph this thing pretty much. So I want you to notice something. First of all, it's negative, so I can kind of almost guarantee that my parabola is going to be going downward, so something like this. And so I haven't even drawn a picture or anything, but let's go ahead. I'm going to go to the calculator, and just to show you, if we were to punch it into any calculator, what would it look like? So let me go ahead and menu, let me clear that. Action, delete all. Yes. Okay, so let me get rid of the table, Control T. That way we can just focus on the graph. So the graph of this particular, I just go to tab, and I have negative x squared plus 36, enter. So, whoa, it's a pretty huge parabola, right? But I think we kind of understood that. I could go Windows, Zoom, Fit, and so on and so forth. Let's do that. So let's menu, Windows, Zoom, and give me one sec, Window 4, and I want to zoom out, or I could zoom square, so it'll just be a square figure that you see. Was not enough, so let me zoom out again. So Window, zoom out is 4. So let me now, I'm just gonna try to move it like that. So whoa, it's gonna cross. It's really, really high, and I can already tell what that number is. That number is at 36 because remember, there are certain things that we know about these particular parabolas. So for example, if it's in standard form, let's try to make it so that we see there is no linear part, right? There's no x. So let's see what the standard form should look like. So I'm gonna just write it this way. Sorry, I should have, let me do the x squared first. So I have negative, you see how I'm just writing it, flipping, I didn't do anything. I just, if the left is equal to the right, then the right is equal to the left. So 0 equals this, but this is what you're used to, or you want your parabola to look like this. Ax squared plus bx plus c. Notice how there is no linear term, and that's going to become important. We'll talk about that in a later section. But if you do notice, there is a c. Your c is your y-intercept. So I know this parabola crosses at 36. So if you notice the little graph that they gave me, I'm going to turn each of these into like 10. So that's 10, 20, 30, 40. So then I know my parabola is going to cross somewhere up here. Now, is it going to be here in the center? Is that going to be the vertex, like at around 36? I don't know. Let's find out. So remember certain things that we know about the parabolas. If I want to find out what the y-intercept is, right? So what do? You place 0 in the x. So I'm going to place a 0 here. So y would equal to, oh, it looks like 36. So guess what? The y-intercept is 0, 36, because I just substituted the x there for the 0. So I've got 1 point. Remember, now we could also figure out the the x point of the vertex, because remember x is like the axis of symmetry, negative b over 2a. So in this particular problem, is there a b? There is no b, right? So I'm going to write 0, and 0 is never negative or positive, right? So I could just, that kind of negative kind of goes away, over 2 times negative 1. So 0 divided by anything is always 0. So, oh, there we go. So I think we found the x-coordinate of our vertex. So the x-coordinate is 0. But look, I already knew that that's also the coordinate of our y-intercept. So guess what? Ooh, nice. Then that means that that is our vertex right there. Now the only thing left over is to try and figure how the x-intercepts. So remember, the roots, x-intercepts, all of those things, all are where the graph touches. So I need to solve for x. Well, look, at this point now take the equation. So the equation tells me negative x squared plus 36 equals 0. To solve for x, you move stuff this way. So I get negative x squared is equal to negative 36. Well, multiply the whole thing by negative 1. That'll get rid, negative times negative becomes positive. Negative times negative, positive. So x squared is equal to 36. So it looks like my x is equal to, now this is where you have to be careful. You take the square root of both sides, but what do you know about the square root of 36? Well, 6 times 6 is 36, but guess what? Negative 6 times negative 6 is also 36. So x could be either positive 6 or negative 6. Yay! So guess what we just found? We just found the roots. So remember, I'm using each of these as 10. So this is 10, 20. I don't need that far. I need a positive 6, so it's about here. And I also, this is 10, so I need about a negative 6, almost halfway. So remember, my parabola was huge. So this one's going to look a little tiny because I was only given that amount of space to draw it in. Wow, it looks like a lot of work, but it's that's pretty much all you need to do to find. I did a little bit extra, obviously, to teach you some of the things, but that's pretty much what you're going to have to do to find what it's asking. So then you can verify in the calculator. We go to Control T. Let's look at the table. We set that at 0, so if I go up, there it is, 0, 36, and we can continue going down. See, notice how it starts. This is one of the roots. When x is 6, we expected it to be at 0. Another root, remember, we set at negative 6, and there it is. When x is negative 6, we have another root right there. So if I were to actually look at the graph, and see where it crosses, let me try to, wow. Let me take away the table so we can see a little bit bigger graph. Here we go. So we count 1, 2, 3, 4, 5, 6, and then negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 right there. So again, you know, there's many different ways of working these problems, but you really do need to practice to try to, you know, get better and better at doing this. So the practice problem, same thing. Try to find the solutions. In other words, I think it's pretty obvious from the picture. This one has 2. This one doesn't have any, doesn't touch the x, and this one has 2. They're tiny, but I think you can figure out what they are. And if you can't find the roots, it says there, just give a you know, más o menos, like it's between this and that, to be able to answer the questions.